Hello all. I just wanted to do a quick factoring review video. I've had several people asking questions, just wanting a few more examples walking through. I know Delta Math had some examples there. I'm going to go through the way you probably learned it in Math 1 doing the STAR method, and really just go through that process again, how to do the whole thing. I'm going to start with a more simple version here. Start with one that where a equals 1, and get something along this line here. The first thing to do is to identify a, b, and c. If you remember your basic form of a quadratic here is this right here, where your a term is with your squared term, which is your quadratic term. Your b is with your x term or your linear term, and then c is your constant, which is just a number. So before we do anything else with this quadratic, to make sure we get a, b, and c correct, we're going to check for a GCF. So on this one, anytime you got GCF, you're checking numbers first, and then you check your variables, your letters. So on this one, if we check our coefficients, our numbers, there's a 1 out front here, and that's the only thing that's going to divide evenly into all of those. So whereas we do have a GCF of 1, we're going to essentially treat it like there isn't one because it doesn't change. And we're going to go straight into finding a, b, and c. So in this case, a is in front of our squared term, and that's just going to be a 1. B is going to be in front of our linear term, our x term, and that's a -9. And then we have c, which is our constant term, which is just, on this one's going to be +8. So after we've checked for a GCF, we're going to go ahead and find a, b, and c. If we have all three, a, b, and c, we're good to go. It can go right into the star that we're going to use STAR method for factoring. If it only has two terms, if it has a and b only, so it's only got the first two terms, it's got a squared term and an x term, then it's set up so that GCF factors it. If it has an a and a c, it can still go in the star and be fine. So know that if you've got two terms, I'll go over some of those as well. This one right here is set up ready to go in the star. So the star, or sometimes called the asterisk method here, is set up so you do a times c on top, you do a on each side, and you do b on the bottom. And I'm also going to put in the sides over here. I call those the sideboards. We're going to check those to make sure those don't simplify, because if they do, we need to take care of that. So what we're going to do, we're going to set up our star with our a, b, and c we've got from this set of problems here. So if you look, we got a times c in the top section, so that's going to be 1 times 8. So 1 times 8, and that gives me 8. A goes on each side, so 1 on each side there. In the very bottom, we have -9. Now, that it's in the star here, it's just like our diamond problems that we were dealing with earlier. So you're trying to see what multiplies to get the top number and adds to get the bottom number. So I'm going to come over here, green, and I'm going to say 8, and I'm going to find my factor pairs that'll make 8. So I've got 1 times 8, I've got 2 times 4, and if I'll just count up, I'll find them all. I go to 3, 3 doesn't divide evenly. I go to 4, and 4 is already on my list right here. So that means I found all the factor pairs of 8. What I'm going to do now is figure out which one of those pairs I can make 9 with, specifically -9, and that's going to be 1 and 8. And the only way I can make -9 with 1 and 8 is to use -1 and -8. And what I do is a quick check here just to make sure that I've got it set up correctly. And the quick test is that you add them, and in this case I get -9, and then you multiply them, and I get +8, because -1 times -8 gives me +8. So what's going to happen, one of these numbers is going to go on the bottom on one side, and the other one's going to go on the bottom on the other side. And it doesn't matter which one's which. I could switch these just as easily, and everything will still work. I'm going to double check my sideboards here. This number here, I'm going to treat those like a fraction. If they simplify, I need to simplify it, but I need to make sure it doesn't go away. So whereas this one here, 1 over -1 would simplify to be -1, I need a top and a bottom. So I'm just going to leave it as 1 over -1 here. Same thing with 1 over -8. That one doesn't simplify, and I'm going to leave it alone. But we'll do one here in just a minute that does simplify, just to show you how that works. So now on the top here, top number is always your number of x's, and the bottom is always your constant. And so what you're going to do is you're going to have two sets of parentheses down here. And one side is going to be one set of parentheses, and the other side is going to be the other set of parentheses. And it doesn't matter which one's which. So on this one, top number is a 1, so it tells me I have 1x. I can just write x, but I'm showing you where these numbers go. And then on the bottom, I've got -1. That's my constant term. I have to write it as -1 down there. I can't change that. That's got to be a -1. I need that sign between it. On top on this other one, I've got a 1, so that's going to be a 1x. Again, I don't have to write the 1 on the x because, I can simplify that, but I'm doing it just to show you where these numbers come from. And then on the bottom, I've got -8. That gives me -8 there. If I had a GCF at the beginning, I didn't, but if I'd had a GCF that I took out, that would go out front here. Okay? So that one is factored, ready to go. Type in, no worries. All right, let's do another example. Okay, this one here, A is not 1. So if you look here, I've got something other than 1 there. So that means that there is a distinct possibility of having a GCF. So first thing I've got to do is check for a GCF. If I do, I look here and, I forgot a squared on that X there. Otherwise I could combine like terms and that would change things. I can pull a 2 out of each of those. They all divide evenly by 2. So I'm going to go ahead and do that. I'm going to pull a 2 on the outside. If I do that, that gives me 2x squared divided by 2 just gives me x squared. 6x divided by 2 gives me 3x. And 4 divided by 2 gives me 2. Okay? Now, I have a new A, B, and C. I don't want to use the old one. I want to ignore it for now. I'm going to use that new A, B, and C there. And I want to be careful here. That A is with that x squared, not that 2. Okay? So we've got A equals 1, B equals 3, and C equals 2. A will not always equal 1. A could equal anything, especially after you do your GCF. It may or may not simplify, may or may not have a GCF, but if it does, A still may or may not be 1. So I just want to make sure you understand A doesn't have to be 1 on there. I'm going to set up my star. A times C on top, so I got 1 times 2, which gives me 2. I've got A on each side, which is 1, and then C on the B on the bottom. Can't talk. B on the bottom, which is 3. So now I'm going to see what multiplies to get me 2 and adds to get 3. And you may be able to do this without, but I'm showing you all the numbers, how this all works here. Got my factor pairs of 2, which is just 1 and 2, which means it has to be that one if it works. If it doesn't work, it's not factorable. That happens sometimes, but in this case it does. So I can do 1 plus 2 equals 3, and 1 times 2 equals 2. So that works out. Again, I can put it in either place. So I'm just going to switch it up just to show you that it still works. I check my sideboards. In this case, 1 and 2 don't simplify, so I'm going to leave that alone. 1 over 1, I could simplify to just be 1, but again, I need it to not disappear. I need numbers on top and bottom, so I'm going to leave it. I'm going to do parentheses. One side here tells me number of x's on top. So that's 1x. Again, I don't have to write the 1. I can just write x. And then a 2, and that's a positive 2, so it's going to be plus 2. The other one, this side over here, is 1 and 1. So I've got 1x plus 1 because it is positive, so it's going to be plus there. I did have a GCF, so I need to make sure I bring that GCF down here and put it out front. This whole thing now is the factored form, okay? GCF being the 2, the factored form being the rest of it here. All right, let's do another example. All right, so here we got another one. Again, A is not 1, so we definitely need to make sure we're checking for a GCF. So if I look here, I don't have anything that divides evenly into 3, 10, and 8. So there's no GCF on this one. I'm still going to identify A, B, and C. So A, B, and C there. So I've got A equals 3, B equals 10, and C equals 8. If I go ahead and identify those, makes it a lot easier to plug in. So I'm going to go ahead and plug those in. So I've got 3 times 8 on top, which is 24. A on each side, so that's 3 and 3, and then B on the bottom, which is 10. Now, be careful here. A is not always 1. I got to put A up there. So in this case, it's 3, not 1. I get people that get in the habit, especially we do a lot of A equals 1, and they think a 1 always goes up there, and that is not the case. So make sure you're putting what belongs up there. In this case, it's a 3. I'm going to go over here to 24. I'm going to find all my factor pairs. 24. So I got 1 times 24. I got 2 times 12. I got 3 times 8. I got 4 times 6. 5 doesn't work. 6 is already on my list right here. So these are all my factor pairs. Okay, again, if you can see the patterns, you don't have to write all those out. I'm showing you the process here in case you need it. Now I need to find which one of these factor pairs I can make 10 with. All right, now on this one, I got to be careful because I have 2 pairs that I could make 10 with. I could do 2 and 12, and I could do 4 and 6. So either one of those I could make 10 with. 2 and 12, I could do 12 and negative 2. 4 and 6, I could do 4 plus 6. So this is where you got to pay attention on there because positive and negatives matter. I need positive 10 when I add them, and I need positive 24 when I multiply them. So if I do negative 2 plus 12, that gives me 10. But if I do negative 2 times 12, that gives me negative 24. So that means that doesn't work. When I do 4 and 6, I do 4 plus 6 equals 10. 4 times 6 equals positive 24. So this one does work. I'm going to use 4 and 6. And again, it doesn't matter which one I put where. So I'm going to use 4 and 6. Okay. I'm going to check my sideboards to see if those simplify. I'm going to treat them like a fraction. So 3/4 doesn't simplify here, but 3/6 does. So what I have here, I'm going to simplify 3/6 like a fraction. So that's going to turn it into 1/2. So I'm going to treat it like 1/2 now instead of 3/6. Okay. So now I get to set up my 2 sets of parentheses. I'm going to set that up. So I got 3 x's on top here. So I've got 3x plus 4 because I got my constant on the bottom. It's positive. This one over here, I'm going to ignore this one now. I'm going to use the simplified version. So now I have 1x. And then on the bottom, I've got a 2, and that's positive, so plus 2. Okay? I didn't have a GCF. I always need to make sure I go back and double check that, but I don't have a GCF, so this right here is my final answer. All right? Let's do one more. So I got another one here. A is not 1, so definitely making sure I check for a GCF first. So in this case, 3, 1, and negative 4. I don't have anything that goes into all of those, so I don't have a GCF. So I'm going to identify A, B, and C. So A equals 3, B equals positive 1, and C equals negative 4. All right, I'm going to set up my star. A times C on top. So it's going to be 3 times negative 4, which gives me negative 12. A on each side, so A is 3 and 3. And then B goes on the bottom, which is 1. So now I'm looking for factor pairs of negative 12 that gets me 1. Anytime I have that factor up top that I'm looking for negatives, I just go ahead and worry about positives, not trying to do the positive and negative version. Just do the positives and then know that one of your factors has to be negative. So I do that here, so it's going to get 1 times 12. I'm going to get 2 times 6, 3 times 4. 4 is my next one, and it's already on my list, so that means I've got all my factor pairs. So I need to figure out which one of those factor pairs I can make 1 with, and that's going to be 3 and 4. So it has to be 3 and 4 if it works. So I'm going to set that up there. I've got 3 and 4 to make 1. The only way to do that is to do negative 3 plus 4. Which gives me 1, and negative 3 times 4, which gets me negative 12. So that works. I'm going to plug in 1 on each side. Doesn't matter which one's which. Then I'm going to check my sideboards here. See if they simplify. 3 over negative 3 does simplify, but I can't, you got to remember, it can't disappear. But I can still divide out of there. So think of it this way. Will something divide evenly into both numbers? In this case, it does. I can get 3 to divide evenly into both of those numbers. So if I do that, that gets me 1 over negative 1. And I'm going to ignore my old set there. If I look at 3 over 4, that does not simplify. So I'm going to leave it alone. I'm going to set up my 2 sets of parentheses. So this one, I'm going to ignore my old set. I'm going to use my simplified set. So that's 1x minus 1. So 1x minus 1. And then over here, I've got 3 on top and 4 on the bottom. So that's 3x plus 4, because it's a positive 4. So 3x plus 4. I go back to the beginning. I check. I did not have a GCF. So that means this right here is my answer. Okay. As you go through these, the most difficult part for most people is going through all the factor pairs here and finding the set that they need. I really recommend take your time if you're struggling just seeing it, because I know some people are better at multiplication tables than others. Use your factor pair list like I got here that I set up, and go on one side and count 1, 2, 3, 4, 5, 6, how many ever you get to until you repeat a number. And sometimes you have a really long factor pair list. For example, if you get a bigger number, something like 60, I mean, if you just backtrack a little bit, one of the bigger mistakes people make is that they forget to check those sideboards to see if they simplify, and you wind up getting wrong answers when you get there. Something you can do 60. So if we got, let's go through that here, 60. So you got 1 times 60, you got 2 times 30, you got 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 doesn't work, 8 doesn't work, 9 doesn't work, 10 is already on my list, so there's your factor pair list, if you had something like that. So I was going to say, you may have quite a few numbers, and the larger the number it is, the bigger the number of factor pairs you have. And that tends to be the trickiest part, is working your way through and figuring out the correct set of factor pairs. One of the bigger mistakes, let's go here, something you can do to check yourself, for those of you that like to do that before you submit your answers on Delta Math. I know it'll work you through it afterwards and give you the work on there, but that way you don't miss it and have to wind up doing more. Something you can check before you submit your answer. If you had 2x plus 7 and 3x minus 9, and the problem you started with is 2x squared minus 7x plus 15. Let's say that was the thing you started with, and that this was the answer you got for your factors. Let's say that was what happened. What you would want to do is you can multiply this out. So you may remember distributive property going through there. So you got to distribute the 2x to everything, and then you got to multiply the 7 to everything. So you would do 2x times 3x, which would get you 6x squared. You would do 2x times negative 9, which gets you negative 18x. And then you would do 7 times 3x, which gets you plus 21x. And then you do 7 times negative 9, which gets you negative 63. And then you would combine those and get 6x squared minus 3x minus 63. Now, if this was what I got for my answer, that should tell me that, oops, I messed up somewhere in my factoring. I did not get what I started with. Okay? That's how you can tell. When you multiply it out like this, you should get what you started with. This one obviously had some sort of mistake because they didn't match. So if I started with 2x squared minus 7x plus 15, when I multiply it out like this, you may have learned it as the FOIL method, depending on your teacher. I don't like the FOIL, say just FOIL method, because when you're doing binomials times trinomials, it doesn't work out that way. But binomial times a binomial, that's 2 terms times 2 terms like this, that works. But just giving you a quick way to check yourself so you know what's going on. And if you have additional questions or you need more examples, please don't hesitate to ask. I'm going to send this to those that ask specifically for it, but I'm going to go ahead and link it to our Delta Math as well. So, as always, if you get stuck, just holler. I'll be glad to help you what I can, and hope y'all are taking it easy.